This is a video for AQA Further Pure Mathematics. This is Matrices 2.3. Well, firstly, I'd like to consider what effect this matrix has on a triangle ABC. So we can do that, of course, by writing down the matrix which represents the triangle ABC and multiplying it by the matrix. So there we have the matrix 0, 0, 2, 0 and 2, 1, which represents the position vectors of each of the vertices. Now this is quite a straightforward calculation to do again, because you can see that what will happen is that the top line will simply be multiplied by 2, so that we get 0, 4, 4, and the bottom line will stay exactly the same, 0, 0, 1. So that means that in fact the x value has just become double its original, so x goes to 2x, and the y value stays the same, y goes on to itself. We say that the y value is invariant. So this is a transformation which stretches along the x-axis, in the direction of the x-axis, by a scale factor of 2. So we talk about it being a horizontal stretch by a scale factor of 2. Well, in a similar way, we can consider what this matrix does, and this time, of course, we can see that the x value is going to stay the same, 0, 2, 2, and the y value is going to be multiplied by 3, so that becomes 0, 0, 3. And so we've got that x stays as it was, but y maps onto 3y. This time then we have a stretch which is parallel to the y-axis, or a vertical stretch, by a scale factor of 3. This now is going to be an enlargement where you can see that the numbers in the positions of the matrix are both the same, so both the x-axis of the x value are going to be multiplied by 2 and the y values multiplied by 2. So from that triangle ABC we end up with one which is twice the size. Notice this time that the invariant, we have an invariant point, which is the origin. So we'd say that this is enlargement scale factor 2, center on the origin 0, 0. So the stretches and enlargements are given by the following set of matrices. The stretches have a value on the leading diagonal of 1 and k, where k is the scale factor of the stretch. The first one there is a stretch which is horizontal, so it's the x value which is increasing. The second one, the y value, is increasing by that scale factor k. The enlargement is can be different values in the x and the y direction. So we'd have what's called a two-way stretch in some text. So we talk about here we've got a horizontal enlargement by a scale factor h and a vertical one by k. If both of those numbers are the same, then we talk about it being an enlargement with scale factor k, and again we have here in both these second two we have an invariant point which is the origin. Here's an example of a sort of question that we might be asked to do in an exam. It says given this matrix T, we first of all need to find T squared. Now remember that T squared is not just a matter of squaring the numbers in the matrix, we need to do the matrix multiplied by itself. So we've got the matrix 1, root 3, and negative 1 multiplied by itself 1 root 3 and root 3 negative 1, and if you calculate that, taking the first row multiplied by the first column gives us 1 plus root 3 squared, so that's 1 plus 3 is 4. And if you then look at multiplying by the second column, then we've got root 3 and then minus root 3, so 0. And moving down to the second row, you'll see that we get 0 the first entry and 4 in the second one. So what describe the transformation represented by t squared? Well, this is an enlargement centered on the origin with a scale factor of 4. You can do some investigation of transformations if you wish by looking at the GeoGebra file, which is given by the link which is on the page here. And that's the end of that particular video, and in section 2.4 we'll look at what happens when we do successive transformations in 2 dimensions.